Mars is the fourth planet from the Sun and the second smallest planet in the solar system, being larger than only Mercury. In English, Mars carries the name of the Roman god of war and is often called the Red Planet. The latter refers to the effect of the iron oxide prevalent on Mars's surface, which gives it a striking reddish appearance in the sky. Mars is a terrestrial planet with a thin atmosphere, with surface features such as impact craters, valleys, dunes, and polar ice caps. Olympus Mons, the largest volcano and highest known mountain on any solar system planet, and Valles Marineris, one of the largest canyons in the solar system, are on Mars. The smooth Borealis Basin in the northern hemisphere covers 40% of the planet and may be a giant impact feature. Mars has two small and irregularly shaped moons, Phobos and Deimos. The days and seasons on Mars are comparable to those of Earth as the planets have a similar rotation period and tilt of the rotational axis relative to the ecliptic plane. Mars has been explored by several uncrewed spacecraft. Mariner 4 was the first spacecraft to visit Mars, launched by NASA on the 28th of November 1964. It made its closest approach to the planet on the 15th of July 1965. Mariner 4 detected the weak Martian radiation belt, measured at about 0.1% that of Earth, and captured the first images of another planet from deep space. NASA's Viking 1 lander transmitted the first images from the Martian surface in 1976. Two countries have successfully deployed rovers on Mars, the United States first doing so with Sojourner in 1997 and China with Zhurong in 2021. There are investigations assessing the past habitability of Mars, as well as the possibility of extant life. Astrobiology missions are planned, such as the European Space Agency's Rosalind Franklin rover. Liquid water on the surface of Mars cannot exist due to low atmospheric pressure, which is less than 1% of the atmospheric pressure on Earth. Both of Mars's polar ice caps appear to be made largely of water. Mars can easily be seen from Earth with the naked eye, as can its reddish coloring. Its apparent magnitude reaches -2.94, which is surpassed only by Venus, the Moon and the Sun. Optical ground-based telescopes are typically limited to resolving features about 300 kilometers, 190 miles, across when Earth and Mars are closest because of Earth's atmosphere. Mars is approximately half the diameter of Earth, with a surface area only slightly less than the total area of Earth's dry land. Mars is less dense than Earth, having about 15% of Earth's volume and 11% of Earth's mass, resulting in about 38% of Earth's surface gravity. The red-orange appearance of the Martian surface is caused by iron oxide, or rust. It can look like butterscotch. Other common surface colors include golden, brown, tan, and greenish, depending on the minerals present. Like Earth, Mars has differentiated into a dense metallic core overlaid by less dense materials. Current models of its interior imply a core consisting primarily of iron and nickel with about 16–17% sulfur. This iron sulfide core is thought to be twice as rich in lighter elements as Earth's. The core is surrounded by a silicate mantle that formed many of the tectonic and volcanic features on the planet, but it appears to be dormant. Besides silicon and oxygen, the most abundant elements in the Martian crust are iron, magnesium, aluminium, calcium, and potassium. The average thickness of the planet's crust is about 50 kilometers, 31 miles, with a maximum thickness of 125 kilometers, 78 miles. By comparison, Earth's crust averages 40 kilometers, 25 miles, in thickness. Mars is seismically active, with InSight detecting and recording over 450 Marsquakes and related events in 2019. In 2021 it was reported that based on 11 low-frequency Marsquakes detected by the InSight lander, the core of Mars is indeed liquid and has a radius of about 1830 plus or minus 40 kilometers and a temperature around 1900–2000 K. The Martian core radius is more than half the radius of Mars and about half the size of the Earth's core. This is somewhat larger than models predicted, suggesting that the core contains some amount of lighter elements like oxygen and hydrogen in addition to the iron-nickel alloy and about 15% of sulfur. The core of Mars is overlain by the rocky mantle, which, however, does not seem to have a layer analogous to the Earth's lower mantle. The Martian mantle appears to be solid down to the depth of about 500 kilometers, where the low-velocity zone partially melted asthenosphere begins. Below the asthenosphere the velocity of seismic waves starts to grow again, and at the depth of about 1050 kilometers there lies the boundary of the transition zone. At the surface of Mars there lies a crust with the average thickness of about 24 to 72 km. Mars is a terrestrial planet whose surface consists of minerals containing silicon and oxygen, metals, and other elements that typically make up rock. The Martian surface is primarily composed of tholeiitic basalt, although parts are more silica-rich than typical basalt and may be similar to andesitic rocks on Earth, or silica glass. Regions of low albedo suggest concentrations of plagioclase feldspar, with northern low albedo regions displaying higher than normal concentrations of sheet silicates and high silicon glass. Parts of the southern highlands include detectable amounts of high calcium pyroxenes. Localized concentrations of hematite and olivine have been found. Much of the surface is deeply covered by finely grained iron oxide dust. Although Mars has no evidence of a structured global magnetic field, observations show that parts of the planet's crust have been magnetized, suggesting that alternating polarity reversals of its dipole field have occurred in the past. This paleomagnetism of magnetically susceptible minerals is similar to the alternating bands found on Earth's ocean floors. One theory, published in 1999 and re-examined in October 2005 with the help of the Mars Global Surveyor, is that these bands suggest plate tectonic activity on Mars 4 billion years ago, before the planetary dynamo ceased to function and the planet's magnetic field faded. It is thought that, during the solar system's formation, Mars was created as the result of a random process of runaway accretion of material from the protoplanetary disk that orbited the Sun. Mars has many distinctive chemical features caused by its position in the solar system. Elements with comparatively low boiling points, such as chlorine, phosphorus, and sulfur, are much more common on Mars than Earth. These elements were probably pushed outward by the young Sun's energetic solar wind. After the formation of the planets, all were subjected to the so-called late heavy bombardment. About 60% of the surface of Mars shows a record of impacts from that era, whereas much of the remaining surface is probably underlain by immense impact basins caused by those events. There is evidence of an enormous impact basin in the northern hemisphere of Mars, spanning 10,600 by 8,500 kilometers, 6,600 by 5,300 miles, or roughly 4 times the size of the Moon's south pole, Aitken Basin, the largest impact basin yet discovered. This theory suggests that Mars was struck by a Pluto-sized body about 4 billion years ago. The event, thought to be the cause of the Martian hemispheric dichotomy, created the smooth Borealis Basin that covers 40% of the planet. The geological history of Mars can be split into many periods, but the following are the 3 primary periods. Noachian period named after Noach's Terra, formation of the oldest extant surfaces of Mars, 4.5 to 3.5 billion years ago. Noachian age surfaces are scarred by many large impact craters. The Tharsis Bulge, a volcanic upland, is thought to have formed during this period, with extensive flooding by liquid water late in the period. Hesperian Period, named after Hesperia Planum, 3.5 to between 3.3 and 2.9 billion years ago. The Hesperian Period is marked by the formation of extensive lava plains. Amazonian Period, named after Amazones Planitia, between 3.3 and 2.9 billion years ago to the present. Amazonian regions have few meteorite impact craters but are otherwise quite varied. Olympus Mons formed during this period, with lava flows elsewhere on Mars. Geological activity is still taking place in Mars. The Athabasca Valles is home to sheet-like lava flows created about 200 Maya. Water flows in the grabens called the Cerberus Fossae occurred less than 20 Maya, indicating equally recent volcanic intrusions. The Mars Reconnaissance Orbiter has captured images of avalanches. The Phoenix lander returned data showing Martian soil to be slightly alkaline and containing elements such as magnesium, sodium, potassium and chlorine. These nutrients are found in soils on Earth, and they are necessary for growth of plants. Experiments performed by the lander showed that the Martian soil has a basic pH of 7.7, and contains 0.6% of the salt perchlorate, concentrations that are toxic to humans. Streaks are common across Mars and new ones appear frequently on steep slopes of craters, troughs, and valleys. The streaks are dark at first and get lighter with age. The streaks can start in a tiny area, then spread out for hundreds of meters. They have been seen to follow the edges of boulders and other obstacles in their path. The commonly accepted theories include that they are dark underlying layers of soil revealed after avalanches of bright dust or dust devils. Several other explanations have been put forward, including those that involve water or even the growth of organisms.